We're going to be finding x and y intercepts to these following rational functions. And when you do that, you're solving it just like you did when you were finding x or y intercept for any function. To find a y-intercept, or where it crosses the y-axis, you let x equal 0, or all the x's are going to be 0, and then you solve for y. And for the x-intercept, or where it crosses or touches the x-axis, you're going to let y equal 0 and solve for x. The y-intercept is usually the easier one, and it involves just arithmetic. Before we get to the first problem, though, I do want to see if I can simplify, just like we've done before. And I see that all of these numbers are even, so I'm going to take out a 2 out of the numerator and a 2 out of the denominator. So the 2's cancel. So the function that I'm looking at is this one. Now I'm going to go ahead and find the intercepts. So again, the y-intercept is usually the easier one. We plug in a bunch of zeros for all those x's. So now finding the y-intercept. And again, when you take out the x, put in the 0 with parentheses around it. Otherwise, it's going to look like 30 and 20 in there. All right. Simplify the top, and if you need to, use your calculator, and we end up with a positive 2. Simplify the denominator, we get negative 4, and negative 2/4 is negative 1/2. So for a y-intercept, we have the point when x equals 0, remember x goes in the first position, y equals negative 1/2. To find an x-intercept, we go back to our function that's reduced, and I'm going to let y equal 0 this time. So I have 3x squared minus 2x plus 2. And on the bottom, x squared minus 4. So this is the one that requires a little bit of algebra to find those x-intercepts. And one thing I'm going to do is I'm going to cross multiply. You can put any number divided by 1 and clear the fraction. You can also multiply both sides by the denominator. It'll do the same thing. So I have 1 times the numerator is just going to be the numerator. Equals, and then 0 times the denominator is just going to be 0. So notice what I did here was just let the numerator equal 0 to find the x-intercept. If you tried to factor it, you wouldn't be very successful. There's no combination that's going to work here. So I'm going to try just the quadratic formula and see what I end up with. So opposite of b, plus or minus the square root of, negative 2 squared is 4, minus 4ac. All divided by 2 times a. Right. Compute the radicand, leave the square root on there, but just compute the radicand, and you end up with, what, 4 minus, what do we get, 24? So 4 minus 24, negative 20, which tells me that this is an imaginary number. So there is no real x-intercept here. So at this point, we have no x-intercepts. That happens. But if it comes up imaginary, you can't have an x-intercept then. So we only had a y-intercept for this problem. All right. So now let's go down to the you try it ones here. We'll find the y-intercept first of all of these, and then go back and find the x-intercepts. So again, you'll want to see if you can factor and cancel. And we can try it with this first one here. We're going to have x minus 7 doesn't factor. And the denominator here, x minus 3 times x plus 2. That negative 3 times positive 2 gives me negative 6, and negative 3x plus 2x gives me the negative 1x. Thing is, though, it doesn't, nothing canceled, so we might as well have just stopped here. But you don't know that until you've tried. So going ahead and going back to the original here, I'm going to let my x's equal 0. I'm going to take out the x's on the bottom. And I have negative 7 over negative 6, or 7, 6. So I have a y-intercept at 0, 7, 6. And then for the x-intercept, again, I can just set the numerator equal to 0. Get a little tight in here, but we'll just squeeze it in here. Set the numerator equal to 0. Add 7 to both sides. So I've got an x-intercept at 7, 0. Okay. Well, let's go down to b here. So again, try to factor it, see what you end up with. So this is going to be x minus 7, x plus 1. And the denominator, I need 2x times x. And the negative 1, so I'm going to have to multiply to get negative 1, so it's going to have to be a positive times a negative. And then check the middle term to make sure that it adds up to negative 1x. So a positive 1x and 2 times negative 1 is negative 2x. That'll add up to the negative 1x that you need in the middle. But again, nothing canceled, so there's no real point. We could go back to this. Or we could use the one we factored, either way. It's just easier to go back to this one when I start looking for y-intercepts, for example. Because when I want to find the y-intercept, all of these x's are going to be zeros. So I'm looking at the constants of both the numerator and denominator. Everything else got zeroed out. So I end up with a negative 7 on top and a negative 1 on the bottom. All right, so that's going to give me the point 0.07. Then go back to the numerator, set it equal to 0 to find the x-intercept. So for my x-intercept, well, I've already factored that, so let's just use that. X minus 7 times x plus 1 equals 0. Set each factor equal to 0. Solve for x. And this one happens to have 2 x-intercepts. So one is going to be at the point 7, 0, and the other one is going to be negative 1, 0. Let's go back up to C here. Factor, see if we can cancel. So out of the numerator, I can factor out an x. Out of the denominator, nothing factors. And once again, there's nothing that cancels, which means I can use my original problem here to find my intercepts. So go back to the y-intercept. We're going to let x equal 0. I end up with 0 divided by negative 1. If the 0 is on top, the answer is 0. So I have a y-intercept at the point 0, 0. Find the x-intercept. I set the numerator equal to 0 and then solve. Well, again, there is the advantage of I've already factored, so set each factor equal to 0. Solve for x. And once again, I'm going to get two x-intercepts, one here at 0, 0, and the other one at 6, 0. All right, so for the last one again, factor what you can first to see if there's anything that cancels. And in this case, when you take out an x, you're going to be left with x minus 1 over x minus 1. So when I cancel, remember at x minus 1 equals 0 or x equals 1, that's where you have a hole. So where you have a hole, you can't have an x-intercept or y-intercept or anything crazy like that. That's a hole. So what I'm left with is y equals x. So if I want to find the y-intercept, let x equal 0. And if I want to find the x-intercept, let y equal 0. So the x and y-intercept are both at 0, 0. If I hadn't done that, and I set the numerator totally equal to 0, I would have said x minus 1 equals 0 or x equals 1 is an x-intercept. But remember, it can't be an x-intercept because that's where you had a hole. That was a factor that canceled out. So you can't have a hole and an x-intercept at the same time.